The helmet, the boots, the uniform. Before a soldier fires a single shot, before they carry a single weapon, they wear the military's first answer to a simple question. How do you keep a human being alive long enough to fight? It starts at the bottom, and the bottom is uglier than most people realize. World War I. American soldiers shipped to the Western Front in wool uniforms that soaked up water and never dried. Leather boots that rotted off their feet inside the trenches. Trench foot claimed more men than some offensives. The uniform wasn't a piece of gear, it was a liability. The military's first lesson in combat equipment wasn't about firepower. It was about survival before the fight even started. Then came the helmet. The M1, iconic, instantly recognizable, and quietly dangerous. The original chin strap design transmitted shockwave energy directly into a soldier's jaw during nearby explosions, snapping necks, fracturing skulls. Soldiers started wearing the strap loose, against regulation, because experience taught them what the designers hadn't considered. The Army eventually redesigned it. They didn't announce why. Vietnam compounded every lesson. Jungle fatigues trapped heat. Boots designed for European terrain fell apart in Southeast Asian humidity. Soldiers developed immersion foot within days. The environment ate the gear faster than the enemy could. The pattern was already clear. Every piece of basic kit the military issued came with a hidden cost. A design flaw discovered not in a lab, but on a body. Modern issued gear reflects those casualties directly. Flame-resistant fabrics, climate-adaptive boots, helmets engineered around blast physics, not just ballistics. Every upgrade traces back to a specific failure, a specific soldier. The foundation looks simple. It isn't. It never was. Well, but the grunt's kit is just the floor, because the moment a soldier picks up their rifle, the real problems begin. The M16 arrived in Vietnam with a reputation it hadn't earned and a flaw nobody admitted. The Army issued it to soldiers with a promise. This rifle was self-cleaning. No maintenance kits were distributed, no cleaning equipment. The weapon, soldiers were told, didn't need it. That claim was wrong in ways that got people killed. In the humidity of the Vietnamese jungle, the M16 fouled rapidly, rounds misfired, bolts locked. Soldiers pulled triggers in the middle of firefights and heard nothing. After-action reports from 1967 described men found dead beside disassembled rifles, attempting to clear jams under fire with no tools, no training, and no time. The weapon had failed them completely. The Army had chosen sophistication over reliability. The jungle voted otherwise. The contrast across the tree line was impossible to ignore. The Soviet AK-47 operated on looser internal tolerances, a design choice that looked like imprecision, but functioned as genius. Dirt, moisture, rough handling. The AK kept cycling. Vietnamese fighters carried weapons that shrugged off the same conditions that were killing American rifles. The reliability gap became a Cold War embarrassment. It forced a reckoning inside U.S. procurement that took years to resolve. Before the M16, there was the M14, its own kind of failure. Quieter, but just as costly. The M14 was designed for full automatic fire. In practice, it was nearly uncontrollable on that setting. Recoil and muzzle climb made accurate automatic fire almost impossible. Most were permanently configured to semi-automatic before reaching soldiers' hands. A weapon built for one purpose, neutered before it ever reached the field. It served briefly and was replaced after only a few years on the front line. 3 rifles, 3 procurement decisions, each one driven by theory, each one corrected by combat. The military's rifle history isn't a story of innovation. It's a story of hard lessons absorbed slowly, at enormous human cost. Reliability beats sophistication every time, in every environment. The soldiers carrying these weapons proved it, whether the procurement system was listening or not. But a rifle is only the beginning, because once the squad is armed, the military starts asking what else they can carry into the fight. The M249 squad automatic weapon was supposed to solve a problem, and for a while, it created several new ones. By the 1980s, the U.S. military needed a light machine gun that could give infantry squads sustained firepower without slowing them down. The M249 was the answer. On paper, it was everything the Army wanted. In the field, it was a different story. The feed tray jammed, constantly. These soldiers in early fielding reported stoppages mid-firefight, the kind of failure that doesn't just cost time, it costs lives. The barrel overheated after sustained fire and warped, throwing rounds wide. And the weight distribution was so front-heavy that gunners humping it through rough terrain were exhausted before contact was even made. The weapon that was supposed to amplify the squad became the squad's biggest maintenance burden. Then there was the M203 grenade launcher. Elegant in concept. A 40mm grenade launcher mounted under a rifle, turning every infantryman into a one-man fire support element. But early doctrine failed the hardware. In Vietnam, soldiers were trained to aim it like a rifle. Direct, flat trajectory. The M203 doesn't work that way. It arcs. Rounds landed dangerously short. Friendly positions were threatened. It took years of hard field experience to recalibrate doctrine to match what the weapon actually did. The most expensive failure came later. The XM307 Advanced Crew-Served Weapon, a programmable grenade system designed to make crew-served firepower smarter, lighter, and more lethal. The military invested over $100 million. The prototype was too heavy, too complex, and too fragile. It couldn't survive the environment soldiers actually fight in. The program was quietly canceled. The money was gone. The problem it was meant to solve remained. Specialist gear is where the stakes multiply. Jammed rifle hurts one soldier. A jammed squad automatic weapon exposes an entire element. A misunderstood grenade system endangers the people it was meant to protect. Every failure at this level isn't just mechanical, it's tactical. But firepower only wins the fight you can see. And on the modern battlefield, the soldier who sees first wins first. The Starlight scope weighed nearly 10 pounds, needed a bipod to operate, and drained its batteries in under an hour. And it was still considered a revolution. Before night vision, darkness was a tactical equalizer. Both sides went blind after sunset. The side that moved at night moved on faith. Vietnam changed that calculation slowly and expensively. The first-generation Starlight scopes amplified ambient light, moonlight, starlight, enough to see movement in the dark. But they were enormous, fragile, power-hungry. Soldiers on long patrols watched them die mid-mission, leaving them more exposed than if they'd never carried them at all. The technology promised a decisive edge. The hardware kept failing to deliver it. Communications had the same problem, just with higher stakes. Vietnam-era tactical radios operated on frequencies so poorly secured that North Vietnamese commanders reportedly monitored U.S. unit movements in real time. Ambushes were laid based on intercepted transmissions. Soldiers died because the gear that was supposed to coordinate their safety was broadcasting their position to the enemy. The military didn't fully reckon with that vulnerability until the SINCGAR's encrypted radio system arrived in the 1980s. A decade too late for the men who needed it most. Optics told a parallel story. Early rifle scopes fogged in humidity, cracked in cold, and lost zero after a single hard impact. Snipers zeroed their weapons at dawn and found them unreliable by midday. Entire engagements turned not on skill, but on whether the glass held together. Then, the technology caught up. Slowly, then all at once. By 2011, the raid on Osama bin Laden's compound was conducted almost entirely in darkness. Operators moved through the building using panoramic night vision that gave them a full field of view, something that would have been science fiction to the soldiers squinting through Starlight scopes 40 years earlier. No moonlight required, no bipod, no dead batteries. Seeing the enemy transformed warfare, but seeing them wasn't enough if a bullet could still find you first. That problem, protection versus mobility, has been haunting military designers for over a century. The Brewster body shield weighed 40 pounds, stopped rifle rounds cleanly, and was abandoned within months because the soldiers wearing it couldn't reach the enemy. That was 1917. The math hasn't changed since. Every generation of military planners has faced the same brutal trade-off: add protection, sacrifice mobility. The history of body armor is the history of that tension, played out in metal, ceramic, and Kevlar across a century of warfare. And the military kept getting the balance wrong long after it should have known better. Korea and Vietnam sent soldiers into combat wearing flak jackets engineered primarily against shrapnel. Against rifle rounds, they offered little meaningful protection. These soldiers knew it. They wore the jackets anyway because something felt better than nothing. Studies conducted after Vietnam found that a significant percentage of fatal wounds were potentially survivable with better armor. The gear existed. The issued protection wasn't it. The PASGT vest arrived in the 1980s as the military's serious attempt to correct that gap. It was heavier than anticipated. It rode poorly on female soldiers. A design oversight rooted in the assumption that body armor only needed to fit one body type. That assumption persisted across multiple procurement cycles, generating replacement programs and retrofit costs that ran into the hundreds of millions of dollars. A problem visible from the first fitting, ignored for decades. The weight debate never resolved. It metastasized. Marine Corps studies on fully loaded infantry found that soldiers were routinely carrying loads exceeding safe limits for sustained movement. Armor, ammunition, water, communications gear stacked onto frames already at their limits. Protection increased. The human cost of carrying it increased with it. Modern plate carrier systems addressed the modularity problem. Scalable threat levels, better weight distribution, gender-appropriate fits finally standardized. The lessons from a century of failures were incorporated. Slowly, reluctantly, after enough casualties to make ignoring them impossible. The armor got better. It always does, eventually, but armor only protects the body on the conventional battlefield. At the highest levels of warfare, the soldiers doing the most dangerous work stopped waiting for the procurement system to protect them and started building their own solutions. The OICW was supposed to replace two weapons at once and ended up being worse than both. The Objective Individual Combat Weapon Program launched in the 1990s with an ambitious premise: combine a precision rifle and a programmable grenade launcher into a single platform that one soldier could carry. The military spent over $100 million developing it. The prototype weighed more than 18 pounds. It shattered under standard drop tests. It was canceled before a single unit reached the field. The failure wasn't surprising to the people who actually fight. Special operations soldiers had already figured out what the procurement system kept refusing to accept: that the best gear isn't always the most expensive gear. It's the gear that works when everything else is going wrong. DevGru and Delta Force operators had been proving that for decades. While conventional units waited years for approved equipment to move through procurement channels, Tier 1 operators were quietly sourcing commercial hiking boots, civilian plate carriers, and suppressed rifles that the standard army couldn't requisition. They didn't look military, they were more lethal because of it. The gear served the mission, not the other way around. The suppressor's journey through the military establishment tells that story precisely. For decades, these suppressors were treated as assassins' tools, Hollywood props, not serious hardware. Military doctrine dismissed them. Then the data arrived. Studies showed suppressors meaningfully reduced permanent hearing loss in operators running sustained operations. More critically, they improved in-team communication during firefights. Soldiers could hear commands without shouting, coordinate without breaking cover. Special operations units began fielding them quietly. Now they are standard issue across multiple U.S. Special Operations Forces. The institution eventually caught up to what operators already knew on the ground. That gap between what the procurement system builds and what fighters actually need runs through the entire history of special operations gear. The soldiers at the tip of the spear have always been the military's most honest product testers. They don't file reports, they just stop carrying what doesn't work. But the quiet professionals paradox holds across every era. The most capable soldiers in the world often wear no rank, no unit patch, and gear sourced from commercial catalogs. The $25,000 prototype failed. The $800 plate carrier didn't. History keeps delivering the same verdict. Simplicity survives, complexity collapses. And nowhere does that lesson hit harder than when the gear gets bigger. The M2 Browning has been firing continuously since 1933, and the military has spent decades trying to replace it with something better and failing. That longevity isn't sentimentality, it's a verdict. The M2 is heavy. It requires a crew to operate effectively. By modern standards, it is an old design solving an old problem. And yet it remains in active service across dozens of militaries worldwide because nothing built to replace it has survived contact with the real requirements of the battlefield. The XM312 program learned that lesson expensively. Designed to deliver the M2's firepower at a fraction of the weight, the XM312 prototype overheated so severely during sustained fire evaluations that testing had to be halted. The program was canceled. The M2 stayed. The Bradley fighting vehicle arrived in the 1980s carrying its own baggage. Early mechanical failures were frequent enough that crews developed dark nicknames for it, the death trap among them. Congressional hearings were held. The program was nearly canceled multiple times. Then, the Gulf War happened. Bradley's outperformed expectations so decisively that the narrative reversed almost overnight. What changed wasn't the vehicle. It was the years of operator feedback that had quietly forced design revisions before the shooting started. The soldiers who hated it had improved it without getting credit for doing so. Even the food tells the story. The meal ready to eat, the MRI, entered service as a caloric solution to field nutrition and became one of the most consistently despised pieces of issued gear in military history. Early versions were so unpalatable that morale studies flagged them as a genuine readiness concern. The menu has been revised 27 times since 1981. 27 attempts to solve a problem that comes down to one simple truth. A soldier who won't eat the ration isn't getting the calories the mission requires. At the crew-served level, failure doesn't punish one person. It punishes everyone depending on that system simultaneously. The M2 understood that implicitly. It just worked. And in a century of military gear evolution, quietly working turns out to be the rarest achievement of all. Talos was supposed to be the future, an armored exosuit that would make special operations soldiers nearly invincible. And it never left the laboratory. The Tactical Assault Light Operator Suit program launched in 2013 with a bold promise: full-body armor, integrated sensors, superhuman strength. The imagery was deliberate. Military officials literally invoked Iron Man in press briefings. Congress was enthusiastic. The defense industry mobilized. 6 years and $80 million later, the prototypes couldn't walk reliably across flat ground. The program was canceled in 2019. 0 suits were fielded. It wasn't an isolated failure. The Raytheon XOS exoskeleton demonstrated 17 times normal lifting strength in controlled laboratory conditions. Impressive footage, promising numbers. Then engineers took it outside. Heat built up inside the frame with no solution. Power cables tethered operators to external sources. The joint lock failures left wearers completely immobilized, more vulnerable than if they'd worn nothing at all. The most advanced strength amplification system ever built turned its operator into a stationary target. The pattern was familiar by then. The more ambitious the program, the harder the fall. Then something unexpected happened. While billion-dollar exosuit programs collapsed under their own complexity, a $2,000 commercial drone changed the battlefield permanently. Ukrainian forces in 2022 took commercial DJI drones, the same models hobbyists fly over parks, and adapted them into precision strike platforms within weeks of the invasion beginning. Platoon-level units suddenly had persistent aerial surveillance once reserved for generals, real-time intelligence, eyes above the tree line, no procurement cycle, no $80 million program office, just soldiers solving problems with available tools. The same instinct that drove operators to choose commercial boots over issued ones decades earlier. The IVAS program, Microsoft's HoloLens-derived combat goggle awarded a $22 billion contract, told the same cautionary tale one more time. Soldiers in field testing reported nausea, persistent headaches, and visual lag that degraded mission performance. Congress froze procurement in 2023. In the most expensive heads-up display in military history sent fighters home with migraines. The lesson accumulates across every act, every era, every failed program. Gear doesn't win wars. People do. The $80 million exosuit failed. The $2,000 drone succeeded. The M16 nearly broke an army. The AK-47 outlasted empires. The Starlight Scope died mid-patrol. The trained soldier carrying it adapted and moved on. Every level of military gear tells the same story. Not of technology triumphing over chaos, but of human beings refusing to let their equipment be the reason they didn't come home.